Good morning, friends. My name is Kiran and my branch is Mechanical Engineering. Today, my subject is Solid Mechanics and Materials. Here we can see my topic is today Microstructure Property Linkage in Alloys. Here we can see what are the linkage in alloys are there of microstructure. Here we can observe that introduction to microstructure property linkage in alloys. This presentation explores how the microstructure influence the property of alloys. Actually, this presentation can helpful for understanding the what are the microstructure properties are there in alloys. Understanding this linkage is crucial for designing materials with uh, desirable characteristic. Here the linkage is because of this linkage only we can say the property linkage in alloys of microstructure is designable because of the material. Through the material only we can see the which properties usually based on the properties. Microstructure property relationship helps optimize alloys performance in various application. This was one of the thing. And other thing is fundamentals of alloys microstructure. What are the fundamentals alloys in microstructures are there? We can observe here. Alloys microstructure consists of phase, grains, and defects that determine the material behavior. Yes, exactly. Now we can see that main based on the defects and grains and phase, we can say the behavior of material, which is which type of material and which type of material is suitable for this type. At the same time, microstructural features includes gain size and phase distribution and what is this? Prediction. This through these three types features, we can say that the microstructure material based on the behavior, and we can say that which type of metal we can use. And other thing is these features are influenced by allowing composition and processing the conditions exactly. And types of microstructures in alloys. What are the types we can see? We can see here. Common microstructure includes axial and dendritic and layered structures. These are three types of common microstructures. And microstructures can be fine or coarse, affection and mechanical and physical properties. Based on the mechanical and physical property, the microstructure can be fine or the coarse. And the microstructure type is typically controlled through solidification and heat treatment processes. And influence of gain size on properties. What are the gain size, or what is gain size and what is the influence on properties of linkage of alloying? Here smaller gains generally enhance strength and toughness due to grain boundary strengthening. Larger gains may improve ductility but can reduce strength. Yet small gains are mainly used for the toughness due to the gain boundaries, and larger gains are nothing but ductility because of the reduction of strength. And grain size control is a key factor in tailoring alloys properties for specific application. Grain size are mainly the useful of the tailoring alloys. Tailoring means alloy means happing and changing the shape of alloying in specific application. It means at the situation. And role of phase and uh, precipitation. Phases and precipitations can strengthen alloys through mechanism like precipitation's hardness. Precipitation hardness means changing the hardness of the given material, like using with the help of the mechanical systems. And the distribution and size of precipitation influence hardness and crack resistance. Controlling phase formation is essential for optimizing alloys performance. And microstructure and mechanical property. Microstructure Microstructure directly affects properties such as tensile strength, ductility, and toughness. These are the mechanical property. Mechanical property is important because of through the material only we can identify the properties such as tensile strength and ductility and toughness. For example, martensic structures provides high strength but lower ductility. Because of this thing, we can say through the property of high strength but lower ductility. And understanding this relationship allows engineers to predict and improve alloy behaviors. And next point is microstructure and physical property. Now, in previous slide we can see mechanical. Now we can see physical properties. Properties like electric conductivity and thermal expansion are influenced by microstructure features. Exactly. And homogeneous microstructures tend to enhance uniformly in physical properties. In physical properties, there is only one which is useful, means homogeneous. Homogeneous means nothing but same microstructure. After the influence of future conductive electric applying electric conductivity, and before they have same microstructure structure, because of the enhance the physical property, because of the alloys have the thermal applications, because through the modification only we can say either they have the thermal applications or not. Processing techniques to control microstructure. Techniques such as casting and forging, heat treatment, and alloy modify microstructure. Casting means nothing but we can do any cavity. Through the cavity we can do, because of the casting we can number of material can be created through the in the small time. Forging means changing, and heat treatment nothing but any, if there is a metal like gold or anything, through the heat we can change the direction, and we can convert through our which we need the shape, we can convert it through the help of heat treatment. At the same time, rapid cooling can produce finer microstructure, improving strength. Because of through the improving the strength, we can say the material will be modified through the microscope. At the same time, the proper processing ensure that uh, desired microstructure and consequently the target properties. Through the properties only we can observe also. And case studies in microstructure property optimization. What are the property observation? Optimization means nothing but observation. And here aluminum alloys with optimized precipitation distribution exhibit improved strength to weight ratio. Because of the aluminum alloys have the low strength, through that only we can see it have the strength to weight ratio, because of the alloys low of the toughness and reductionness. And steel microstructure control through heat treatment enhance toughness and hardness. Exactly, in the previous aluminum also we said there is only toughness, here there at the same time hardness also, because of the having the low treatment. At the same time, this example demonstrate the practical importance of microstructure property in linkage. Here we can see that the conclusion and future direction. What are the conclusions today? Deep understanding of microstructure property relationship is vital for the advanced alloys development. Here vital means nothing but it is important for advanced, because of when we are in going deep, it is very important. What is means nothing but microstructure property relationship. And embracing techniques like additive manufacturing offer new way of tailoring microstructure, and continuous research will lead to smarter and high performance alloys for the further technology needs. Here we can see recall what we need, what we learned here. Here the topic is microstructure property linkage in alloys. In alloys, what are the microstructure property linkage are there? We can see that through the topic only we can understand. And introduction is nothing but the this presentation will can help us for the understanding the relation between linkage in alloys and what are the microsuperstructure. At the same time, here microstructure property relations help to optimize the alloy performance in various applications. In various and different applications, we can see the alloys performance. Fundamental of alloys behavior is there is through the defects and gains we can determine the material behavior, because of the each there is a different material which have different defects. Through we if we can we see the defects and gains means we can definitely identify the material, because of the we know the defects. At the same time, other features not compared to other thing, we can say the gain size also, because of the it have distribution of composition of processing. And types of microstructure alloys are nothing but aquazel and dendritic and layered. These are three types. And there is a one more thing of microstructure property is fine and cohesive. These are the two things we can learn, and they mainly affect on the mechanical because of the using of the alloys. And influence of gain size on property is nothing but it have toughness due to the boundary. In a smaller gain, generally it has strength, because of toughness is due to grain boundary, and larger it have ductility, but not as compared to other it has reduced the strength. And roll of phase is a prediction is nothing but it has a mechanism like precipitation of hardness. This was one thing. At the same time, it have the craft resistance, means small resistance compared to other things. And microstructure and mechanical property. Mechanical property means nothing but tensile strength, ductility, and toughness. These are the property of mechanical properties. At the same time, it provide high strength but lower the ductility. This was one of the example which can see in the mechanical property. And microstructure and physical property. Here physical is nothing but it has the thermal expansion because of the electric conductivity. This was one thing we need to remember. And here processing technique to control microstructure means there is three: casting, forging, and heat treatment. These are three types which modify the microstructure. And there is a ratio because the strength to weight. That's one thing we can remember because of the optimizing in aluminum alloys. And conclusion is nothing but it have the manufacturing offer for the high performance alloys to future technology needs. And thank you.